All right, this one says to solve the differential equation d2y by dx squared minus 10dy by dx plus 29y equals 7e to the 2x. So to solve this differential equation, it's first thing we know to do is solve the auxiliary equation. Solving the auxiliary equation, I'm going to go back to u. This is just u squared. Let's go again. This is just u squared minus 10u plus 29 equals 0. That would be the auxiliary equation for this differential equation. Now, I'm not going to lie to you. I don't look like I can factorize it so easy. And so I'm just going to draw for the magic calculator. I'm going to draw for the magic calculator. Let's go, magic calculator. And it will solve it for us. Using the calculator, we know u will be quadratic formula. It is b10 plus the square root of b squared, which is 10 squared minus 4 times a is 1 times c, which is 29, divided by 2a, which is 2. Magic calculator. Math error, so we know it have complex solution. The solution is complex, so we're gonna have to do it. So it is good to use a calculator. Yeah, man. Put the calculator away. So it's good to use. It's good for us to do it ourselves. So doing it ourselves, what we're gonna get is u is equal to minus b, which is 10, plus or minus the square root of b squared minus 4ac. It's going to be 10 plus or minus 10 squared minus, it's 10 squared minus 4 times a times c, and c is 29, and this is being divided by 2. This is divided by 2. So let's go ahead now and work out what we're getting for u. So what we're going to get for u is u, all right, let's do it down. So what we're going to get now is u is equal to 10 plus or minus 10 plus or minus. Now simplifying this now, we're going to be getting, all right, 10 squared is 100. 100 minus 4 times 29, just to be safe, 4 times 29, I'll put that in my calculator. That's 116. So 100 minus 116 is negative 16. So this is the square root of, negative 16. And this is being divided by 2. Nice. So what that will work out to be is u is equal to 10 plus or minus 10 plus or minus the square root of negative 16 is 4i over 2. That's 4i over 2. Nice. This is what we have. And so what this works out to be is u is equal to 10 over 2. 10 over 2 is 5 plus or minus 4 over 2. That's just 2i. Now that allows us to write down the complementary solution. So the complementary solution, or the complementary function CF, is going to be given by, I like to call my complementary function YC. So the complementary function YC is equal to, remember it is now e to the real part times x, so it's e to the 5x times, in bracket, it's going to be a cos, a times the cosine of 2x plus b times a times the cosine of 2x plus b times the sine of 2x. That's what we're going to get, plus b times the sine of 2x. That is what we shall get, plus b times the sine of 2x. Easy, soft. So this will be the complementary function. Since this is a complementary function, we're good. We just need to find the particular integral now. So yeah, man, let us go ahead and find the particular integral now. So to find the particular integral now, what we're going to be solving again, remember it was y double prime minus y prime minus 29y equals 0. This was what we had. Let's just check back to make sure. Y double prime minus y prime minus 29. Yes, that's also what we had. Plus 29, sorry. This should have been plus. And the question had said it equals 7e to the 2x. So let me fix this to 7e to the 2x. 7e to the 2x. So again, we know that our particular integral, which we're trying to find, our particular integral, we're going to call it yp. Yp is equal to some constant. I like to call my constant q. So it's qe to the 2x. Then now our y prime, yp prime, is going to be the derivative of this, which is 2q e to the 2x. Then we find our second derivative now, and our second derivative, yp prime prime, is going to be 4q times e to the 2x. This is what we're going to get. And so this is what we get now. And so let us do this. This is what we do. So we work this out now. And what we're going to get is y double prime, which is 4q times e to the 2x, 4q times e to the 2x, minus yp prime, which is 2q e to the 2x. Then you have plus 29 times y, which is plus 29q e to the 2x, and that is equal to 7e to the 2x. 7e to the 2x. And now we need to simplify and find what is q. So let's see what we work out. 4q minus 2q is, all right, it's giving me a headache. 4 minus 2 plus 29. All of this work out to be 30. What is that? 31. I'm getting 31q times e to the 2x. That's what I'm getting. 31q times e to the 2x. All right. Just want to make sure I transfer the question correctly, because something looks suspicious. I see what I didn't transfer correctly. This part right here, I didn't transfer, I didn't put the 10y prime. So then it would have been 10 times this. 10 times this would have made it 20. And then that means this wouldn't be 31. This would be 4 minus 20 plus 29. Because it would be 10 times 2 here, minus 20 plus 29. So 29 minus 20 is 9. Then 9 plus 4 is 13. So this is 13q. That's equal to 7e to the 2x. So all we have to do now is equate 13q to 7. And so 13q would be equal to 7. And so that means q equals 7 over 13. That's all. Q is equal to 7 over 13. Since Q is 7 over 13, then that means we have our particular solution. Our particular solution from here is then going to be y is equal to 7 over 13 e to the 2x. 7 over 13 e to the 2x. That's what we get. 7 over 13 e to the 2x. That's what we get. Nice. 7 over 13 e to the 2x. So that means now our general solution, and we know our general solution, remember, it's equal to complementary function plus particular integral. So what we're getting is that our general solution y is equal to the complementary function, right back all of that, e to the 5x multiplied by, let's save some space, I might text it. Just to save some space, it will be a cos 2x plus b sine 2x. Yes, man. And then all of this plus the particular integral, which is 7 over 13 e to the 2x. 7 over 13 e to the 2x. Nice and easy and soft. That's all to do this question. Nice and easy, soft. That's the general solution for this question.